So let's imagine that you score an 80 on one of your exams and a 90 on the next one. What is your average, or what is the mean? Given that if there's such easy numbers, to calculate the average, you probably just thought, what is the number that's halfway between 80 and 90? And if you look on a number line, which I've kind of written out over here, you'll see that the average of two numbers is the number that lies exactly in between. So the average of 80 and 90 is 85, because 85 is right in the middle of 80 and 90. So as a side point, when we do coordinate geometry, what you'll notice is that the midpoint formula of 2 points on a plane is actually the average of the x and the y coordinates separately. So let's say you've got these 2 points, a comma b and c comma d. If you take the average of the x coordinates, a plus c over 2, and then the average of the y coordinates, b plus d over 2, you're actually going to get the midpoint, because the midpoint is really the average of the x coordinates and it's the average of the y coordinates. We'll talk about that more when we do coordinate geometry. The other way to do the average is basically the formal way, where you add up the elements, you divide it by the number, and you get the average. So taking our example before, if you did 80 plus 90 divided by 2, you would actually get 85. And this is the easier way to do it, obviously, when you have more than 2 elements. Because on the SAT, most of the time where they ask you for the average, they're going to give you a set with more than 2 elements. Something else to be aware of on the SAT, let's say they don't give you all the information. So what if they say something like the average of n scores is 72? What is the sum? So using the average equation, I kind of wrote it over here. You've got the average, which is 72. You also have the number of elements, which is n. Now, even though you don't know the total, you can write a meaningful expression for this, which is 72n, because if you multiply if you multiply 72 times n, you're going to be able to fill this in. The reason I point this out is because this is going to be useful on the SAT, and I'll show you in some example problems afterwards. And the other things you have to know on the SAT are the median, which is the middle number. So it's the number that divides the 2 in half. One thing to keep in mind is if they're an even number of numbers, the median is the average of the 2. So very quickly, if I gave you a set that said 1, 2, 2, 3, 4, 9. This set has 6 elements and it doesn't have a middle number. So what you do is you take the average of the 2 middle numbers. So 2 plus 3 is 5, divided by 2 is 2.5. So the median of this set is going to be 2.5, which is the average of the 2 middle numbers. Just keep that in mind. The mode is the number that occurs the most. So in this particular set, the mode is obviously 2 because it occurs 2 times. But let's say I added more numbers to the set. I added 2 more 9s. Now the mode is 9. But let's say we scratch off that last 9, and what do we notice? There are 2 2s and 2 9s. So now this set has 2 modes. That's the point that I made here. You can actually have more than one mode. You can have 3 modes, you can have 4 modes. The SAT doesn't really tend to ask that much, but keep in mind. The range is easy to calculate. It's the difference between the largest and the smallest number. So in this particular set, the largest is 9, the smallest is 1. You subtract those 2. And so the range in this particular set, as it's written now, is going to be 8. Now we'll try some problems. The average arithmetic mean of 6, 19, and x is 19. What is the value of x? So this is a simple use of the average formula. So remember, we're going to add everything up, divide by the number, and we'll get the average. So it's going to be 6 plus 19 plus x, all divided by 3 because there's 3 elements, and the average is going to be 19. So how do we figure out x? Just by simple algebra. Multiply both sides by 3, we get 6 plus 19 plus x. The right side becomes 59, 19 times 3. And then we're going to subtract 19 and 6 from the left side. We're going to get x equals 32. And we just solved it by using the average formula. Next question, the average of t and y is 15. The average of w and x is 15. what is the average of t, w, x, and y? So you might automatically know that the answer is going to be 15, because if you combine the two sets, the average is not going to change. What I do want to show you, though, is if we work this out fully, how the average equation actually helps us. So let's set this up. T plus y over 2 equals 15. That's the average of the first set. Then we've got w plus x over 2 equals 15. And that's the second set. And they want to know what is the average of all of them together. So that's going to be t plus y plus w plus x. And that's going to be over 4. And now to figure this out, we need to know the sum. So we don't know what each of these values are, but we do know what the sum of them is, because if we multiply the first equation by 2 on both sides, we're going to get t plus y equals 30. If we do the same here, we get w plus x equals 30. So even though I don't know what t and y are individually, I know t plus y is 30, and I know w plus x is 30. So basically this equation becomes 60 over 4, and the answer is going to be 15, which kind of proves what we knew from the beginning. But what I wanted to show you is that knowing the average equation can actually get you the answer to the problem, even though you might not have all the information in the problem. So that's important. Question 6, if x is the median of the 7 numbers listed above, which of the following could be the value of x? So what we have to do is get these numbers in order first. So just by looking at it, we'll go 3, 4, 10, 15, 18, 21. Now if x is the median, it's got to go right in between, and so the value of x could be anywhere from 10 to 15, and so notice the answer therefore has to be 14. One thing to point out is that x can actually be 10 and it can actually be 15. Question 8. In a certain game, the only scores were 50, 60, 70, 80, 90, and 100. The bar graph shows the scores of 23 children who played the game. Which of the following correctly shows the order of the median, mode, and average? Now, you might actually be able to figure this out just by guesstimating and then eliminating choices. What I want to do in this problem is actually calculate all 3 of these values, because if you get a future problem where you actually have to do it, I want to show you kind of the fastest way. So let's first do the average. Now notice we've got only a possibility of 6 scores, but we do know the number of people who scored them. So what I'm going to do is I'm going to very quickly in my head, I know that 2 people scored 50, so the total in this category is going to be 100. The total in the next category, 3 people scored 60, so that's going to be 3 times 60 is 180. 6 people scored 70, so 6 times 7 is going to be 420. 5 people scored 80, so that's 400. 4 people scored 90, that's 360. And 3 people scored 100, that's 300. And then let's assume this is a calculator problem. If you add all these up, these numbers that we just calculated, divide by 23, what you're going to find is that the average is going to be equal to 76.5, which kind of makes sense because it looks like the middle of all these is somewhere around there. Next, we're going to calculate the median. So the most important piece of information we have first is the total number of children, which is 23. So the way that you calculate the median is you have to figure out where the middle value is. So if you've got 23, the fastest way to do this is divide by 2. 23 divided by 2 is 11 with a remainder of 1. And so your median is going to be the 12th value in the set, because if you have 23 total, it means you've got 11 numbers to the left, 11 numbers to the right, and the 12th value is in the middle. So basically, we just have to count, we have to figure out where the 12th value is. And in this case, what we want to pay attention to is how many children are in each category. So the first one is 2, 3, 6, 5, and so on. And so we want to find the 12th value. So essentially we're counting 1, 2, 3, 4, 5. 2 plus 3 is 5. Plus 6 is 11. plus 5 is going to be 17. So we know that the 12th child is going to be right in this category. And so that tells us that the median or the middle value is going to be 80. And then lastly, the mode is pretty easy because the table lays it out for us. The category with the greatest number is 70. So the mode is 70. Therefore, putting this in numerical value, mode, average, median. Let's do question 16. The median of a list of 99 consecutive integers is 60. What is the greatest integer? So it always pays to kind of map this out. The median is our middle number, so that's 60. If there are 99 integers, I want to know how many is on each side. So 99 over 2, that's going to give me 44, remainder 1, 49 rather. And so that means to the left of 60, there's going to be 49 numbers. To the right of 60, there's going to be another 49 numbers. And they want to know what is the greatest integer. That means the last one. So very simply, you would just do 60 plus 49, and then the answer is going to be 109. Let's try number 14. A list of numbers has an average of 15. If one of the numbers in the list were increased by 20, then the new list would have an average of 19. What is the sum of the numbers in the original list? So for the first list, we know that the average is 15, and we don't know the number of elements, so I'll put n, and therefore we have the sum as 15n. Then it says one of the numbers was increased by 20, and we have a new average of 19. So it's the same number of elements, except the sum is now going to be 15n plus 20. And now they want to know what is the sum of the numbers in the original list. So notice what's going on here. This becomes 15n plus 20 equals 19n. And notice what happens. Subtract 15n from both sides. We get 20 equals 4n. And divide by 4. We figured out n equals 5. Now that we know that n equals 5, the sum of the original is basically 15 times 5, and that's going to be choice D, which is 75. Question 17. There are 17 numbers in a list. If the 5 smallest are decreased by 1, and the 3 greatest are increased by 2, which of the statements must be true? So for problems like these, what I like to do is kind of just simplify. So let's imagine that we've got a list, maybe not of 17, but maybe of like 7 numbers. So let me just make up some numbers. So what are they saying? The 5 smallest are decreased by 1. So imagine if all of these became 2s. And then they're saying the 3 greatest are increased by 2. So these are all going to become 11. So which of the following must be true? The median does not change. Now, the median is always going to be the middle number. So the middle number, if I have 17, and there's a lot more here, let's assume that this is going to be the middle number, even though it's not on my list, but because we have 17, the middle number is actually not going to be affected. It's really only on the ends where something's going to happen. So that actually is true. Now, if A is true, then B has to be false, and so does C. D, the average decreases. So let's look at what happens to the average. We've subtracted a net of 1 on this end, or of 5 I mean, because we took away 1 from each, and we added 2 to 3 numbers, so we added 6. So what's actually going to happen? If we subtracted 5 on one end and added 6 on another end, the mean is actually going to go up, because we've added a net of plus 1. So the mean doesn't decrease, the mean does not change, the mean actually increases. So all these statements are false besides choice A. Question 17, more of a conceptual problem, but I'm putting it in here just for the sake of practice. A fitness center purchased a number of exercise machines, 4 costing $1,700, 8 costing $1,300, X costing $1,200, where X is a positive odd integer. If the median price for all the exercise machines purchased was $1,300, what is the greatest possible value of X? So what I like to do for these is just kind of map out visually what's going on. The greatest cost was $1,700. So we can put that up here. And we know that 4 of those cost 1,700. The median is 13, and we know 8 were in that category. And the lowest price was 1,200, and we don't know how many were purchased there. All we know that is that X is odd. So let's think about it this way. If we want X to be the biggest number possible, that means the median should be the first element in the middle category, and then above the median, if we've already used 1, there's going to be 7 left in the 1,300 category and 4 left in the 1,700 category. So that means we're going to have 11 up here, and then we'll have a middle element here, and then if it's 11 and 11, then the greatest possible value of X has to be 11.